This is the second method of solution of algebraic and tangential equation that we are going to discuss as Regula-Falsi method or method of false position. This is the oldest method of computing of real root, and it is also a faster method than the bisection method. So it converges more faster than the bisection method. The bisection method that earlier we have discussed works like this: that we have a curve y is equal to fx, and we have to find a root between a and b such that fa and fb are of opposite side. The similar outline is also here. Fa into fb would be less than 0. So fa and fb are of opposite sign. So then x is equal to is the abscissa of the point C, where the graph y is equal to fx meet the x-axis. What is the meaning of this abscissa? Because this word may be new to you. Abscissa is the value of a coordinate on the horizontal axis. কোন জায়গায় এই জায়গাটাতে যে হরাইজন্টাল এক্সিস এর যে পয়েন্টটাতে হরাইজন্টাল এক্সিস মিন্স এক্স অ্যাক্সিস এ যে কোনো পয়েন্ট এর ভ্যালু সেটা হচ্ছে এই অ্যাবাসিকা পয়েন্ট বলা হয়. So now how does it work? Formulation is this: to obtain let the chord AB meets the x-axis at a point. Here AB is the chord. This chord meet the x-axis at a point whose abscissa is x1. Now to obtain the value of x, consider the equation of the line AB from A to FA is y minus FA is equal to m into x minus A. This is the equation. Now y minus fa, now how do you find formula? Fb minus fa by b minus a. So y minus fa is equal to fb minus fa by b minus a into x minus a, this x minus a. Now but it meets the x-axis at x is equal to x1. So it at x is equal to x1, y will be 0. So if I just replace here a by here, if I just replace a by x1, then we will have of y will be 0, because at x is equal to x1 it meets the x-axis. So at x-axis we know at x-axis y is equal to 0. So 0 minus fa is equal to fb minus fa by b minus a, x1 minus a. So the value of x1, that is, it is most important here, the value of x1 is equal to a minus b minus a by fb minus fa into fa. This is the value of x1. Now next as it goes, so just we have to do a successive application of the formula that we got for x1, and similarly we get at n plus 1th iteration we have xn plus 1 is equal to xn minus xn minus xn minus 1 by fn minus fn minus 1 into fxn, provided that at each step fxn minus fxn is less than 0. Now there will be either a maximum iteration will be given or an error value will be given less than, you have to achieve an error which is less than that particular threshold. Let us take an example. Log x minus 1.2 is equal to 0. That will be our fx, and with that fx we have to find out the root between the 2 and 3. We have to find out a root between 2 and 3 where fx is equal to x log x minus 1.2 is equal to 0. So I will just compute these things in this table. So here I'll write that fx is equal to, it has also been said that root set lies between a, it starts with a is equal to 2 and b equal to 3. Now I'll just ask you to fill this table by using a calculator. So here, what is the value of a to begin with? The value of a to begin with is 2, and the value of b to begin with is 3. So what is the value of fa? Just find out what is the value of fa, that is f of 2. After one iteration, whenever I put the value of a and b, I see if a is equal to 2 and b is equal to 3, I have fa is equal to minus 0.58, fb is equal to 0.23, and x1 is equal to 2.72, fx1 is equal to minus 0.018. Right. Now, here at the right hand side, see that I have written something. What I have written? I have written if a into fb is less than 0, then the root lies between a and b. Now see that if a is equal to minus 0.58, fb is equal to 0.23. So fa into fb is clearly lying with clearly less than 0. So the root will lie between a and b. Now, if fx1 is equal to fa, the sign of fx1, that is magnitude of fx1 is the sign of that magnitude of fa. This means the 0.58 sign koto minus and fx1 sign koto plus, sorry, minus. So if this happens, then a is equal to x1. A will be replaced by x1. So to start the next iteration, at the very beginning, we got that a has been replaced by x1. So a will be 2.72. And what is the value of fa then? Fa value আমরা আগেই পেয়ে গেছি minus 0.018. What is the value of b? The value of b remains the same, that is 3. What is the value of fb? It also remains the same, that is 0.23. Now I'll again ask you to find out what is the value of x1, a new value of x1. That is, again, the value of b will be changed, value of 8 still remains the same. So I just ask you to find out what is the new value of this. So we are at the second iteration and we find that if x1 is equal, if x1 is equal to 2.745 and if x1 is equal to 0.0038. If a is in negative, if b is positive, and if x1 is positive, so x1 will replace the b. So this remains 2.72 and this still remains minus 0.018. Now b becomes, instead of 3, it becomes 2.745 and fb becomes 0.0038. So now you have to again calculate x1, again calculate fx1, and similarly you will grow. So just I will show you. So this is how it grows. Just I will show you how the exact computation looks when you complete it. There you go. Fx1 is equal to 2.721 at the first test. So fx1 is equal to negative, and if b is positive, then you go this way. You have fx2 is equal to 2.74, fx3 now you will get again 2.74065. So the approximation or the correctness is achieved up to 3 digits after decimal. See, 2.740, 2.740. So we can say that 2.740 is correct answer up to 3 digits. And if you take 4 digits, it will be 2.7405. So 2.74065 is the correct answer up to 3 digits because it does not change after 3 digits. Now, how to find out this solution using R? In R programming, you will use the method Regula-Falsi and it is in the package Pragma. So you have to install package install.packages under the double quotation you will use Pragma, Pracma, and the function is Regula-Falsi function. With f, the function a and b, the initial values, max iteration, the maximum number of iteration it can have, and the tolerance error f silent to the power 0.5. We will not change the last part. Here we use install.packages Pragma library Pragma function is defined same as the bisection method. Function of x is equal to x into log 10x minus 1.2, and then Regula-Falsi, the function that we used is f comma the initial values of a and b 2 comma 3, max iteration 100, and tolerance we does not change these things, is still remain e to the power 0.5. So root of this equation is 2.74064. Just recall the value that we got using our computational method. So f dot root is this is the error and this is the number of iterations. And within 6 iteration, that is within x6, we found the root. So this is how you use your system R programming to find out the root of a transcendental equation using Regula-Falsi method.